All right, so this will be a relatively short intro to sets. So first, what is a set? And for us, it's going to be a collection of objects, generally speaking. And those objects we're going to call elements. So we have two ways of describing sets that we typically use. The first is what we call the roster method, and second is set builder notation. So let's say that we have a set A, and it contains 2, 4, 6, 8, and 10. For the roster method, all we have to do is basically we have to create a set with all of the elements inside of curly brackets, and we'll call that set A. So it'll look like this. Set builder is a little bit different. That's where we're going to actually describe the set. So we'd have set A is given as x such that x is a positive even integer less than, we could say 11. We could say less than 12 if we wanted to. And so this first x here is what a typical element of set A looks like. And the line that we write means such that. So set A is the set of all x such that x is a positive even integer less than 11. We could also write it as set A is equal to the set of all x such that x is between 0 exclusive and 10 inclusive, where x is an element of z. But there's something a little bit off there. And that is we have to say that x is even. All right, so consider the set of positive integers. If we wanted to describe that in the roster method, we would say b is equal to 1, 2, 3, 4, and so on. Those three dots mean that we're going to continue on and on. Set builder notation, we would say x such that x is an element of z plus. So z plus is the set that we use for positive integers, the notation that we use for positive integers. So typically, we use capital letters for sets. So we might have A, B, C, S, T, U, X, Y, Z, and we use lowercase letters for elements, so A, B, C, X, Y, Z, and so on. So let's let A equal 1, 2, 3, 4, 5. Really simple example. So our symbols here, this little epsilon means element of. So for example, we could say 3 is an element of A. And if we cross that thing out, it means not an element of. So we know 8's not inside of set A, so we could say 8 is not an element of A. And when we talk about sets, we usually talk about well-defined sets. That means that there's no ambiguity as to whether or not something belongs to a set. So if I give you the set of integers, you can tell me that pi does not belong to the set of integers, without a doubt. All right, so let's set x be equal to z, which is the integers. And we want to know true or false. So is 4 an element of z? It's true. Is 1/2 inside of z? No. Pi, not an integer, and -8 is definitely an integer. So if set A is the set of really big numbers, we can't even really do anything here because A is not well defined. Who's to say really big is greater than 100 or maybe less than 1,000? We don't really have a clear definition for that. All right. So set operations. First, union and intersection. The union of two sets, A union B, is the set of elements from both A and B. The intersection is the set of elements common to both of those. So whatever they have in common will be inside of the intersection. So let's say that we have a set A, and it contains these elements, a set B with these elements. So if we wanted to make a set A union B, we're going to take everything from A everything from B and put them into the same set, but we don't really list the repeats. So there's everything in A union B. For A intersect B, we have to take everything that they have in common, which looks to be 8 and 3. Two more operations. The difference of two sets. We can either use a backslash or a minus, so A minus B is the set of elements in A but not in B. And then the symmetric difference is the set of elements in A or B, but it can't be in both. So for A minus B, that's going to be 1, 4, 6, and 23. Elements in A that are not in B. And for the symmetric difference of A and B, it can either be in A or in B, but it can't be in both. So that'll be everything except 3 and 8. All right, so for the first thing that we want to do, I'm going to ask you to determine what these symbols mean right here. So they're in books, they're on the internet. Different notes, I probably have them in the chapter that I posted, but these are important ones that we're going to use all semester, so we want to know what these symbols represent. Z we know are the integers, Z plus is positive integers, and so go from there.